Okay, so here we have a projectiles question, and since it's a projectiles question, we need to remember that the only force acting is going to be gravity, which will be an accelerating force downwards. We're told that a ball is thrown from the top of a tower of height 24 meters, so our vertical height, SV, is going to be 24 meters. And first question is saying use two labelled arrows to show the direction of the velocity and the acceleration. Well, the acceleration of any projectile is always going to be downwards in the direction of gravity, and the velocity is always going to be tangential to its path. So at the top here, its velocity would be doing this. But as gravity pulls it down, its velocity is going to be changing all the way along, so it's always going at a tangent to its path. Then it says calculate the time taken from when the ball is thrown to when it first hits the ground. Well, we've only got information given to us in the vertical plane. We know the height that this is. So in the vertical plane, we're going to write our SUVAT and put what we know. We know that the height is 24 meters. We know its initial velocity in the vertical is going to be 0 because initially it's projected horizontally. We don't know what our v is. We know that our acceleration is 9.8 and t is what we are looking for. So we need to pick an equation that has s, u, a and t in, and the best one to use for this is s is equal to ut plus a half at squared. This section here is going to disappear because our initial velocity is 0, so s is equal to a half at squared. So we can rearrange this. T is equal to the square root of 2s over a, which is equal to the square root of 2 times 24 over 9.8, which gives us an answer of 2.2 seconds. Then the next part says the ball hits the ground 27 meters from the base of the tower. Calculate the speed at which the ball is thrown. So we've thrown our ball with a velocity v. It's fallen parabolic trajectory like this. It's travelled a distance of 27 meters. But the key thing here is in the vertical plane, sorry, in the horizontal plane, acceleration is equal to 0 if we're neglecting air resistance. And so I don't even need to use a SUVAT equation for this. I can just use the fact that it travels 27 meters. We know that the time was 2.2 seconds from our previous question. And so I can just use speed, or in this case v, is equal to distance over time. So that's going to be equal to 27 over 2.2, which gives me an answer of 12.27. So I'm going to put that as 12.3 meters per second. So remember, whenever you're doing these projectile equations, sometimes, and this will only ever be the case in the horizontal where you've got no acceleration, but if you're modelling it in the horizontal, sometimes you can just use speed is equal to distance over time.